Hi guys, we'll be learning inequalities today. Okay, so I'm really sorry and thanks for waiting. And okay, let's start inequalities. Hopefully, you guys can hear me.
Yes, sir.
Okay. See, in inequality, it's a really important, really important chapter because this will have all the basic understanding. That means you'll be solving any problem, like mostly in physics. Okay, so you will always be needing inequalities. Okay, inequalities, that means we'll be using most of the words like greater than, less than, greater than, equal to, less than, equal to. Hopefully you all are aware of. Okay, so let's see some of the symbols and what are they called. So let's write words and let's have some examples. Okay, based on that. So symbols or symbol of greater than. Okay, this is called greater than, and let's have the example like x plus 9 is greater than, let's say, 0. Okay, so we'll have some value of x. What will be the possible values of x? Similarly, we have less than. Okay, and so of course, like 9 is less than 18, right? Of course, we all know that. Now, in terms of variable, you can write as many examples as you want. Less than, let's say, 28. Okay, then we have greater than, equal to. Okay, greater than, equal to, or equal to. So let's have example. 5 is greater than, equal to x minus 1. We'll see all the examples one by one, and this is lesser than or equal to. So less than or equal to. See, the meaning of or is either it is less than or it can be equal to 0. Okay, so that's the meaning. We'll see that with the help of examples again. 2y plus 1 is lesser than or equal to 7. Let's say that. Okay. So let's solve some of the problems based on this. Let's say x is less than 5 and y is greater than 11. So what area can you cover? What is the area it signifies? Okay, what is the meaning of this? So that means it has all the possible values of x and y. So x and y both are always positive, right? Means x can be negative as well. So x, let's say the value here, it is 5, the maximum value of x. So this is called critical point. Okay, and y, for y, let's say this is 11. Okay, so it can have all the possible values from here, right? Like if you draw a vertical line here and a horizontal line here on 11, so it can have all the possible values here, right? No, so it is greater than, right? Not less than. So all the possible values. So let's here, this side, this region, all the possible values. Okay, so that is the meaning of this curve. It can have all the possible value. It does not mean that it is having one particular value. Okay, that will again depend upon the equation. That means we are finding a domain of this domain of values where it is possible, where the function is defined. Like in functions we have studied, right? Like some of the functions, when we write a square root of function, any square root, like x minus 1, right? So y is equal to square root of x minus 1. That means whatever is there inside square root, it has to be greater than or equal to 0, right? So it is defined only if x minus 1 is greater than or equal to 0. We have learned this in function while finding the domain and range, right? Because if this is less than 0, what will happen? We'll have a negative value inside square root. So it will become a complex number or an imaginary number. Okay, and we don't want imaginary. We are solving only for real variables. Okay, we are only solving for real variables. Okay, that means x minus 1 has to be greater than or equal to 0. That means x can have all the possible values greater than or equal to 1. That is the meaning. So on number line, if you want to represent this on number line, so now 1 is the critical point, and we have all the values, possible values of x, which is greater than or equal to 1. Okay, so we'll use this symbol. Okay, I'll be darkening this circle. That means we are including the value of x here. That means we are including x is equal to 1. Here this is x is equal to 1, right? This point. That means x is greater than or equal to 1. It can have all the possible values, like it can have the value 10, right? So if you put 10 in this equation, what will get? Y is equal to square root of x is 10, sorry, x is 10 minus 1. So it is square root of 9, which is 3. That means it's a real number. We know it's a real number, right? So if you want to check your answer, let's put x is equal to 0. Okay, so if you substitute x is equal to 0 here, what we are going to get? So y will be equal to square root of 0 minus 1, which is negative 1, which we define as iota, which is imaginary, right? That, and we are defining only for real valued function. Okay, so that's the meaning of greater than, equal to, or lesser than, equal to. Similarly, these all four symbols or the terms we are going to use. Then another important tool, which I suppose you haven't studied, right? So that is called in ratio and proportion it is actually, but let's try to understand it here itself. Okay, so if, let's say, if A, B, C, and D, these are numbers such that B and D are not 0. Okay, B and D are not 0, and there is another condition that the ratio of A by B is equal to C by D. Okay, ratio of A by B is always equal to C by D. That's why we cannot have B equal to 0. B equal to 0 not possible, D equal to 0 not possible, because it will be not defined. Anything upon 0 is not defined, and we don't want that type of function. All right, so what will happen? So first rule we call componendo. Okay, see, these are tools which we are going to use to solve inequalities and other problems as well, and this is valid all the time for any function, any variable. It is always valid. Okay, so it is this, you can write componendo is A plus B. Okay, that means you will be adding the numerator and the denominator and writing the denominator as it is in both sides. You just do that both sides. That is called componendo. Okay, and of course B and D cannot be equal to 0. All right, so the second one is dividendo. Anybody know what a dividendo is? So instead of plus, instead of adding, we'll be subtracting. So A minus B upon B should be equal to C minus D upon D. Okay, so this is always true. You can check any function. Let's say A is, we are just taking example. A is equal to 1, B is equal to 8, C is equal to let's say 2, so D should be equal to 16. That means we know here for this A by B is equal to C by D, right? This is true, isn't it? Because 1 by 8, my mistake, 1 by 8 is equal to 2 by 16. This we know for a real, when we substitute this real value, it is always true. So let's try to solve this 1, 8. Now using componendo, using this first one. Okay, let's use componendo. Okay, so if you solve componendo here, what you can write? So A plus B, that means 1 plus 8 divided by 8 should be equal to 2 plus 16 divided by 16. Now, is it true? So the numerator, it will become 9 by 8, and the denominator, it will become 16, 17, 18 by 16. So is it true? Yeah, it's true, right? It is true, isn't it? Because this is 9 by 8. What 9 by 8 is equal to 18 by 16, because you can write 9 into 2 divided by 8 into 2, and 2 and 2 will get cancelled. So componendo, we verified componendo. So componendo is true, right? Now let's verify dividendo. Okay, let's try to verify dividendo. So it is 1 minus 8, right? 1 minus 8 upon 8 should be equal to 2 minus 16, right, upon 16. So what this will become? minus 7 by 8, and that in the right hand side we have minus 14 upon 16. Now this also we can see it is true, right? This is also true. So componendo and dividendo both we have verified. It is always true. So the third one is if, oh, okay, it's called, let's see, componendo we have done, and okay, now the last one, let's write componendo and dividendo. Componendo and dividendo in the same equation. If we do dividendo, right? So this you can write if, that means of course a by b is equal to c by d. Then we can write a plus b upon a minus b is equal to c minus d, sorry, c plus d upon c minus d. Okay, this is just Latin name, componendo, dividendo, that's it. It's a Latin name. Okay, these names are in Latin, so it is always true. There is another operation that is called the fourth one. Let's write alternando. So alterando or alternando, I forgot. I think alterando. Okay, alterando. So if a by b is equal to c by d, so of course it is a by c is equal to b by d. We just cross multiplied it. And let's write the fifth one, the last one is invertendo. That means if a by b is equal to c by d, that means b by a should be equal to d by c. Yeah, we just need to cross multiply it, right? So we have these equations, or we can say these are the tools that we are going to use. All right, got it? So let's solve some of the problems based on this, and we'll check what does it mean. Okay, so let's write our first problem. 3x is less than 7 plus, okay, let's write 7 plus 7. That's it. 3x is less than 7. What are the possible values of x? Yeah, anyone, please tell me what will be the possible values of x. Anybody is there online?
Yes, sir. Yes, sir.
Okay, so yeah, tell me what will be the possible values of x. It's really easy, right? So did you listen to everything, right? Means whatever we have done.
Yes, sir. Yes, yes.
Inequalities we are studying, and I'm trying to finish it fast. So just try to understand. Let me know if you have faced any difficulties in this. Okay, so we have learned some tools, that is your componendo, componendo and dividendo. All right. So similarly, we can verify all, like we have verified componendo and dividendo. You just need to take the ratio of equation number 1 and 2, and you will get componendo and dividendo. That's it. Okay, so if 3x is lesser than 7, what are the possible values of x?
1 or 2, sir.
No?
Oh no, sir. It can be anything from negative to 0, 1, 2, sir.
Okay, see, these type of problems, what we will do for simplification, what I'm trying to tell you, you do any operation you are performing, you perform in both side of the this equality or the greater than symbol, whatever it is, in the left hand side and the right hand side. So suppose here we just want x, so let's divide this equation by 3. So if we divide this equation by 3, what we are going to get? Both side we are divided, so x is lesser than 7 by 3. See, I know most of you can directly just say, okay, yeah, of course x should be lesser than 7 by 3. But when we have complicated equations, these are really important tools. This is how we are going to perform, okay, the operations. Okay, so this means x, so this is called critical point. Whatever the possible values of x, that means if you put, instead of lesser than sign, if you put equality sign, okay, let's say 3x is equal to 7. So whatever the value of x you are getting, that is called the critical point. Okay, so if you substitute it like this, if you substitute any equation is equal to, instead of like greater than or some symbol, so you'll get x is equal to 7 by 3, and this is called critical point. Critical point. Okay, now critical point here is 7 by 3. We are plotting only on x-axis. Okay, now it says it should be lesser than 7 by 3. Now if it is lesser than 7 by 3, that means all the values lesser than this, but 7 by 3. 7 by 3 we are not taking into consideration. Okay, so we can write this as in brackets, we can write. So here we have minus infinity, we have this side as positive infinity. So we write from minus infinity to 7/3, and we'll be using open brackets to represent it. Okay, like this example when we are taking, so here we'll be using closed bracket, right? So you will write x for a possible value. So x belongs to, this is how we write x belongs, see we have studied this in function, x belongs to 1 to infinity, right? So infinity, it will always have open bracket because infinity is not defined. Okay, infinity is not a number, it cannot be defined, right? But we are considering x, so we'll use closed bracket here. This is called closed bracket, and this one right here, it is called open bracket. We have studied these parts in functions in the first chapter itself, right? So this is how we are going to represent. All right, x belongs to 1 to infinity. Like why infinity is not defined is, let's see with the help of a number line. Okay, so if suppose we have a number line here, hopefully everyone knows this, but I'll just repeat it. Okay, nothing fancy here. So suppose you have numbers 0, 1, -1, 2, 3. Now how you will define infinity? Because there are infinite numbers between 0 and 1, infinite number of real numbers. Here also infinite real numbers, right? Between 0 to 2 also we have infinite numbers. So infinity is not defined, infinity is not a number. Okay, so for in real numbers, infinity is not a number, infinity is not a real number, that's it. Okay, now okay, so see, we have to study that in terms of two variables. Right now, as of now, whatever we have been seeing, that is all like in one variable. We either finding x is equal to like x is what we are finding, x is equal to 0 or greater than 0, or y is lesser than 0, whatever we are finding. We are not finding in terms of two variables, x and y. Okay, so see, right now we are having introduction of inequalities. Later on we'll be solving problems from your book as well, but there are some simple rules that we need to follow. Like one of the rules to solve inequality is if a by b is greater than c by d, c by d. Okay, if let's say a by b, the ratio is greater than c by d, then what we can write, b by a should be lesser than d by c. Okay, so see, this sign changes, the greater than will become lesser than. Let's prove it using example. Like 1 by 2 is greater than what? Let's say 1 by 4. Okay, 1 by 2 is greater than 1 by 4, of course. Now, so if we take the reciprocal, okay, if you take the reciprocal of this number, okay, so reciprocal of this number, like this and 1 by 4, reciprocal of these numbers, so the sign will change, right? That means 2 is lesser than 4, that we know. I know it's a really simple rule, but here we all make mistakes. Okay, most of the time we make mistakes here, so always be careful about this. See, another one is while taking negative sign, like let's say some equation, or let's say -1 is greater than -2, right? So if you multiply both side by -1, okay, if you multiply both side by -1, the symbol will change again. Okay, so if we multiply both side by a negative number, okay, so what will happen, the sign will change, the sign will reverse. Okay, like if you, let's multiply -1 with any negative number, let's say -10. Okay, let's multiply it by -10. So, and here it will be -2 multiplied by -10. Of course, the equality sign will change because it will become 10, which is always lesser than 20, right? So take these things into consideration or every time. See, one is your when you are multiplying it with negative number, and Another one is when you are taking the reciprocal of the number. Okay, these are really important rules. Okay. Okay, let's go to NCERT book and try to solve some of the problems. Okay, so we have question number 2 from the example. It is solve if 5x plus 3, sorry, it is minus 3 is lesser than 3x plus 1. Yes, try to find the value. You have to find the value of x if x belongs to integer. Okay, if x is integer. Yes, tell me. See, first we always try to eliminate the constants. Okay, and we try to keep the variable in the left hand side. So what we'll do, we will add 3 both sides. Okay, so if 3x minus 3, we'll add 3 plus 3. Okay, so we'll add 3 here. All right, so it is lesser than 3x plus 1.
X is less than 2.
X is less than 2. Okay, x is less than 2, but you have to find the value of x if x belongs to integers. Okay, x belongs to z, I've written, right? So this will be 5x. 5x should be lesser than 3x plus 4, right? Now what next we'll do? What next we can do? Just tell me.
Subtract 3x on both sides.
We'll subtract 3x on both sides because we don't know x is a variable, right? And 5 and 3 both are positive numbers. We can do that. So 5x minus 3x. So let's write in green. Minus 3x. Okay, should be lesser than, see, symbol is not changing. So this is 3x plus 4 minus 3x. I know you all know how to solve this, but again, so 2x should be lesser than 4, right? Now we will divide both sides by 2. All right, so what we can write, 2x should be lesser than 4, and let's divide both sides by 2, right? So what it will become, x should be lesser than what, 2. Now what are the possible values of x if x belongs to integer? So the possible value of x will be all negative integers. X will be equal to all negative integers. So let me write z minus, if that's okay with you, z minus plus plus 0 and 1. Okay, it is not equal to 2 because we are not there is no equality sign. If here we have equality sign, okay, if we have equality sign, then it will also be equal to 2. Then again we'll take 2 into consideration. All right, but here we don't. So how do we write this? So we'll write x belongs to all integers, all, let's write negative integers, belongs to z minus, okay, union 0 and 1, right? That's how we are going to write it. All right. So okay, so hopefully the rules are very much clear to you guys. Let's solve another problem. Let's say 62 plus 48 plus x upon 3 should be greater than and equal to 60. Okay, just try to solve this problem. See, the whole chapter is this. Okay, whole chapter is this. See, I wanted to start statistics, but it's better if we learn inequalities first, because there will be uses of inequalities in statistics. Yeah.
Sir,
Yeah.
greater or equal to 70, sir.
How much?
Greater or equal to 70, sir.
Greater than or equal to 70.
Yes.
Okay. Anybody else? It's a relatively easy problem, right? First you multiply both sides by 3, then you subtract both, 48. Yeah. So subtract both sides. You can just add this, right? 48 plus 62 will be 110 plus ax upon 3 is greater than equal to 60. Now let's multiply by 3 both side. Multiply it by 3 both side. We can do that. So this 3 and this 3, the ratio will be 1. There we get 110 plus x should be greater than equal to 180. Okay. Now we'll subtract 110 both sides. So 110 plus x minus 110, and this is greater than equal to 180 minus 110. How much this will become? So this will be x should be greater than and equal to 70. Okay, so that's the answer. Okay. All right. Now in exercise 6.1, we have all similar type of problem. I know you guys have already done this because you have had exam of this chapter, right? In your school. So you must have solved this. So let's go to exercise 6.1. Exercise 6.1, and just solve question number 10. Question number 10. Okay, just solve question number 10, which is x by 3 should be greater than x by 2 plus 1. So see, they right now here we are having ratio, so be careful about this. How we are going to solve it? How are we going to solve this?
So first have a common denominator and then
Yeah.
multiply.
Yes, correct. So it will be x by 3 greater than x plus 2 upon 2, right? Now we'll multiply both sides by 2. So let's multiply both sides by 2. So it will become 2x upon 3 should be greater than x plus 2, right? Now let's multiply both sides by 3, right? So this will become 2x greater. We are multiplying by positive number, right? Only positive number. We are not multiplying by any negative number. So sign will not change. It will not reverse. So it will become 3x plus 2. Now can we subtract 2x both sides? We can do that, right? So let's subtract 2x both sides. So this side will become 0. That means 2x minus 2x is greater than 3x plus 2 minus 2x. Okay. So what this will become? 0 is greater than x plus 2. Now let's subtract 2 both sides. So what this side will become? Negative 2 is greater than x. That means x is lesser than negative 2. X is lesser than negative 2. Okay. So x is all possible values. All possible values of x is lesser than 2. That means the open graph, okay, like this. So this is negative 2. It is called critical point. Critical point. Okay. So we can write x belongs to minus infinity to 2 minus 2 and both open bracket. Okay. So all these values are possible except negative 2. All right. Similarly, see, you have all you solve all the problems. I'm very much sure that all problems are really easy, relatively easy. And tomorrow we'll see how to solve using graphical methods. Okay, I'll just give you one example of graphical method, like y is equal to the classic example x square, or x square. Let's say x square. Okay, so we have a graph let's draw the graph in x and y. So not equal to, let's say it is greater than or equal to x square. Okay, so what will be the possible values? X square. So this is y, this is x. Now how do we draw y is equal to x square? We kind of know that, right? So I'll just directly draw it. Okay, so this is y, this is the function. Y is equal to x square. Y is equal to x square, right? Now we need all the values of y which is greater than or equal to x square. So what will be the area, shaded area? So this is the reason we are talking about, right? Here the value of y is greater than equal to x square, because let's say x is equal to x is equal to what? 10. Let's say x is equal to 10. So what we are getting, y should be greater than or equal to 100. So only here we can get, right? Or let's say x is equal to 1. So y should be greater than or equal to 1. So if x is equal to 1, y is equal to 1 here. See, 1. That means we should get all the values above this line. Okay, y should be greater than or equal to 1. So this above this line. Okay, so these type of problems we are going to solve, all right, using graphical methods. And first, obviously, we are going to see the linear graphs, that means the straight lines, and what does it mean. Okay, the inequalities. All right, so I know you're having a chemistry class right now, and I'm really sorry I was stuck in traffic, so couldn't come on time. I'm really sorry about that. And thank you so much. I'll see you tomorrow.
Thank
You
you,
just
sir.
try to solve this exercise 7.1, this 6.1, and I'm sure most of you will be able to solve all the problems. If we have any doubt, please ask me tomorrow. Okay, thank you.
Sir.
Thank you so much.
Sir.